Hi guys, welcome back to my channel Pirai Academy. In this video, we are going to see about Leetcode question number 712. Minimum ASCII delete sum for two strings. Given two strings S1 and S2, return the lowest ASCII sum of deleted characters to make two strings equal. So if the S1 and S2 are C and E, then I can tell you I want to delete this S and this T from each of the string such a way that I can get EA and EA where this EA and EA are same. Okay, and this is going to be the minimum value, right? Because S ASCII value is 115 and T's ASCII value is 116. By adding these two things, we will be getting 231. So this is going to be your minimum ASCII deletion. Okay, apart from that, I can also delete SA and AT, but here the ASCII value for the deleted elements will be maximum. But in question they are asking us to find the minimum. Okay, and here delete and leet. Here I can just delete DEE in my S1 string and E alone in my S2 string such a way that both the strings will be equal to LET. Fine, that's the reason why the output is 403. Okay, fine. So the simplest approach or the brute force approach that comes into our mind is greedy approach, right? And how my greedy approach going to be working here? So if this is the given value, right? Okay, given example, then I'll be taking 2 pointers. Let me copy this. Yes, so I'll be taking 2 pointers. One pointer will be pointing at this first string, another pointer will be pointing towards the second string. Now D or L, so which is greater, which is smaller, that's what I want to remove, right? In question they are asking us to remove what? Remove the minimum things, right? But both the strings should be equal at last. So among these two things, D and L, which is minimum? D is minimum, so delete D, which means I want to add 100 in my result. Okay, and move my pointer to the next thing, E and L, no, they are not same, so E is the least thing, so I want to delete the E, so plus 101. Now go to the next string. Now L and L are both are same, so skip. Okay, what is the next thing? Here it is E and here it is E. Okay, fine. Okay, go to the next thing. Here it is T and here it is E. T and E, which is maximum? T is maximum. So I want to delete this T. Okay, so E is minimum. So I want to delete the E. Okay, if I delete it, it will be 101. Okay, and move to the next thing. Here also T and here also T. Okay, so I don't want to do anything. Skip means go to the next thing. Next thing means here there is nothing. Here there is nothing, which means I want to delete all the things from these pointer. Unfortunately, we have only one thing. Okay, E alone. So plus 101. Okay, so what is the total? It is 304. So this is what the output they are asking here also. 403. Okay, so this is what the output we got in our problem statement also, right? Now if you think this greedy approach works, it doesn't work. See here, for this particular example, C and eat, here itself the greedy approach not works. Let me show you. C, eat. Okay, let me show you. At first my pointer will be standing here and here. Whether these both the things are same? No. Which is smaller? E is smaller, so it will be deleting E. But we know S and T should be deleted, but here E is deleted, so here the algorithm will be wrong. That's the reason why we cannot use the greedy algorithm, because we are not sure that deleting the minimum element will be guaranteed that we will be always ended up in minimum as our answer. Okay, so whenever the greedy fails, where will we going? We will be going for the recursion. So in your technical round, they don't give this sample input. Okay, I mean they don't give this first example as a sample input. They only give the second example and example like this in your sample input, such a way that you will be thinking via the greedy algorithm, but when you are submitting it at 200 20th test case or 300th test case, this first example will be given. That so it is hidden. Okay, so whenever it is a hidden test case, you cannot see it. So you'll be confused like what error I made in the greedy algorithm rather than thinking of what algorithm I made. Can you understand this? So there the usage of greedy itself wrong. That's the reason why I am just telling you with this example. Okay, whenever you are using a greedy, just think about for 5 to 10 minutes whether it is correct or not with some examples. Okay, if it is wrong, just go for the combination. Combination means absolute recursion. Okay, so if you don't know about the recursion and backtracking, just go and watch my video for that. I will be giving that link in my description. Go and watch about recursion tree, recursion stack, and how the recursion works in via DFS approach. Okay, if you already know it, don't worry, just continue this video. See here. So here we are going to use the recursion, right? So first step for using the recursion is we want to make sure what is going to be my varying parameter in my function. So this is going to be my function, and what are those varying parameters? I want 2 pointers. One pointer will be taking the responsibility of tracking the current position of the string 1, and another one is for string 2. So I want 2 pointers ij. You may take any name, that's your wish. Okay, initially where I am starting, I going to start from 0, 0 such a way that I am going to check whether these both the things are same. If it is same, don't worry, just move on. If it is not, I have two choices, right? So see this, here 0 is D and here 0 is L. Okay, which means I can either delete D or I can either delete L. Yes, so here only in greedy algorithm we have confusion whether I want to delete D or I want to delete L. But now in recursion we are going for all possible combinations, which means I can either delete D and go for one branch, and also I can delete L and go for another branch. So if I delete D, which means here comes what is the D's ASCII value? It is 100 plus where my function goes to. I deleted D, I didn't touch the L, so L remains same. D alone deleted and moved to the next index. Okay, similarly if I delete L, then what is the ASCII value of L? It is 108 plus. So where should I change my function? The JS pointer will be changing to 1. Can I understand this particular line? Yes. Again 1 and 0. 1 and 0 means I am standing at this particular point E, and here it is L. Again it is not same. Not same means again go and delete E first. If I delete E first, it will be 101 plus f of 2, 0. If I delete L, it will be 108 plus f of 1, 1. Okay. Similarly here 0, 1. 0, 1 means it is D and E. Okay. Here also I have two choices. Either I can delete D. If I delete D, it will be 100 plus f of 1, 1. Or if I delete index number 1, sorry, E. Okay. If I delete E, it will be like 101 plus f of 0, 2. Yes. Okay. Now 2, 0. 2 is L and here 0th index is also L, which means it is valid. Whenever it is valid, I don't want to do anything, just skip. Skip means just go to the next thing. 3, 1 like that. Can you understand this? Similarly here it is 1, 1. What is 1? 1 is L and 1 is E, and here also it is E. So here also don't do anything, just skip 2, 2. Okay. Here again 1, 1. Here also 2, 2. Okay. Here it is 0, 2. 0, 2 means D and E. So here also you want to do two steps. One is I can either delete D. If I delete D, it will be 100 plus f of 1, 2. If I delete E, then it will be 101 plus f of 0, 3. Yes. Now again, what is the third index? Third index is E, and what is the first index? It is also E, which means I just skip. So skip means f of 4, 2. Here 2, 2. 2 is L and here 2 is E. So here I have two choices. Either I can delete L. If I delete L, it will be 108 plus f of 3 comma 2. If I delete E, then it will be 101 plus f of 2 comma 3. Okay, here also similarly 108 plus f of 3 comma 2, and here it will be 101 plus f of 2 comma 3. Okay, now here it is 1 comma 2. 1 comma 2 means 1 refers to this E and 2 refers to this E. So here they both are same. So I will be skipping it, f of 2 comma 3. So here 0 comma 3. 0 comma 3 means I am standing at this particular point D, and here it is T. So here I have two choices. Either I can delete D or E. So if I delete D, it will be 100 plus f of 1 comma 3. If I delete T, it will be something like, what is the T's ASCII value? 116. 116 plus f of 0 comma 4. Okay. Now understand this clearly. After this, I don't want to continue this branches. I want you to do this. I want you to complete this recursion tree. Okay. Understand here. So what this signifies? This signifies my I pointer is at 0th index, but my j pointer is at where? Is at the ending. Okay, which means I finished my second string. I only have my first string starting from 0. Okay, which means I want to replace this as what? I want to replace as s1 of 0 plus s1 of 1 plus going up to s1 of n. Take all these ASCII values and replace for this particular function. Can I understand this, what I am doing here? Yes, because see here, s2 is exhausted. Then remaining is only s1, some particular indices. So I want to delete those indices. That's it. That's the last choice I have, right? So instead of that f of 0 comma 4, I want to replace the bottom thing. Okay. Similarly here, if it is of take for example f of 6 comma 2. If it is like this, what should I do? So first string is exhausted. Meanwhile, in my second string, I must be starting from this 2 and going up to the end, and I want to delete everything, right? So I will be just instead of this, I will be taking what is the E's ASCII value, it is 101, plus what is T's ASCII value, it is 116. So instead of this, I will be replacing like this. Now can you understand the base condition? Okay, and so let me write here what are the base condition. So the first base condition is if my I is equal to my length, then what should I do? I want to add sum all the things which are from j to m, the length. Okay, if j is equal to m, then sum all the I to n. Okay, if I is equal to n and also j is equal to m, then what should I do? Just to return 0, because I exhausted both the things. I don't want to delete any of them. Can you understand this? So these three are going to be base condition, and your body of the recursion is going to be, you want to check whether both the things are same. If it is so, skip to the next index, or else you want to just consider whether I want to whether I want to delete from the S1 or I want to delete from the S2. That's it. So this is going to be your entire recursion code. Okay. Now tell me what is going to be the time complexity. So time complexity will be O of 2 power m cross n. Okay. Space complexity will be O of m cross n. That's it. So this is going to be your time and space complexity analysis for this recursion code. So let me show you the recursion code. So this recursion code is of Java. If you want C++ or Python, just go and find out in description. Okay. So see here, I assigned S1, S2 and M and N as a class data members. Okay, and I initialize them here. Fine. Now here, what is my recursion call going to be? It is 0, 0. It is 0, 0. And then here, what is the base condition? If I is equal to M, so there I represent the S1 length as N, but here it is M. Okay. If I is equal to M, then what should I do? I want to start from J, go up to N and take all the characters and take their sum and return it. okay, because I want to delete all these characters. Similarly for s2 also, if j is equal to n, so in this case also, if, see here, I forgot to add one more thing. If you do not add that also, that's totally fine, okay. If you add this, that's also totally fine. If I is equal to m and j is equal to n, then what should I do? I should return 0. If you don't add this step also, that's fine, okay. If you add this also, that's fine. This is optional, okay. Okay, fine. What is the body of the recursion going to be? If both the characters are same, then I want to skip them, or else I want to return the minimum among them. I forgot to tell the minimum, right? Okay, you have doubt why I am returning here the minimum, because see here in the question they are asking us to find the lowest possible deletion. In our recursion, what we are doing, I am checking whether if I delete ith index, what is going to be the result. If I delete the jth index, what is going to be the result. So from those things, I want to take the minimum among them. That's the reason I am taking this minimum. Sorry, I forgot to tell that. Okay, fine. So this is going to be your entire recursion code. Fine. So this is of time complexity exponential, right? So I want to optimize this so that you will not get the TLE. So let me optimize this. Before that, let me copy this. Okay, fine. Now let me copy this. Now we are going to optimize this using memoization technique. So what is mean by memoization? Memoization means I am going to store in my memory for all the scenarios. If it is again occurring, then I will be taking out from the memory. Like let me write this first, memoization. So we can do this using hash map or using array. Now I will be showing you using the array. By learning about the array technique, your job is to do this hash map. Okay, so see here in your recursion, follow the white color. So here it is f of 2 comma 2, and here also it is f of 2 comma 2, right? And here it is f of 1 comma 1, and here also it is f of 1 comma 1. So as you know, recursion is a DFS. We first compute this particular value by using all these recursion calls, right? Then only we are going to this. Okay, if I store the return value of this in my memory, why should I go for all this recursion call? Instead of that, I can directly return here itself, right? So that's the concept of memoization. Okay, so how I am going to do the memoization technique? So first of all, I want to design the array. So here, how many varying parameters are there? So there are two varying parameters. One is I, another one is j. So here I can confirmly say that it is 2D array because two varying parameters. If three varying parameters, is 3D array. Okay, so 2D array. Okay, now the next step is I want to determine what is going to be the size of this array. Okay, so listen this carefully. This I can be reaches from where to where. This I can be going from 0 up to n. I can be going from 0 up to n, and j also can go from 0 up to. So in my coding path, I written here as m, right? So here also let me continue with m and n. Okay, here also it will be n. Can you understand this? Apart from that, it cannot go because if I reaches m, it will be the base condition. If j reaches the n, it will be the base condition. That's the reason why I will be going up to where m, which means inclusively it will be m minus 1 and n minus 1, which means 0, 1, 2 going up to n minus 1 m. So this is going to be your I. Okay, similarly for j, it will be 0, 1, 2 going up to where n minus 1. Okay, so this is going to be your entire matrix. Now in this matrix, the next step is what should I fill it with? Okay, what should I initialize it? So see here, in this entire recursion tree, which value will not return? Always the positive value will be written or 0 will be written, right? Can you understand this? So I can tell you, I will be just assigning any negative value or infinity or minus infinity or null. Okay, if I for example, here I will be initializing like minus 1, everything is minus 1. Fine. So or else you may also go with null also. Fill everything with null. That's your wish. But it should not be repeated in the return statements. Okay, fine. So this is the first step. The next step is go to the base condition. So this is the last base condition. After the last base condition, add one more base condition. If, take for example, this is the dp. Okay, if dp of I and j is not equal to -1, if you use null, here also use null. Okay, return dp of I and j, that's it. Okay, and then after computing some values, you want to store them, then only return. So at this particular line, instead of returning directly, you want to store it, like return dp of I and j is equal to dfs of I plus 1 and j plus 1, like that. Okay, similarly here also, at this particular line also, before returning it, you want to store it. Return dp of I and j is equal to minimum among these two things. Can you understand this? Okay, so what I done here is, in these two lines, I am just updating the values. At this particular point, I am just checking whether it is already computed. If it is already computed, then there won't be any -1, right? If it is not -1, then it is already computed. So directly I will be returning it instead of going for any other recursion calls at below. It doesn't even go to the body of the recursion. So now tell me, what is the time complexity? Time complexity will be hugely reduced to m cross n, and space complexity will be also O of m cross n. So this is very much efficient, right? Yes, from exponential to polynomial. Fine. So let us see the code for this, then we can further optimize that. So see here, this is going to be your memoization code. Memoization, actually it is very easy, and I want you to complete the recursion tree, and also you want to complete the memoization technique for hash map. Okay, now see here, what are the changes I made? The first change is I initialized a memo array, okay, of size m cross n. Okay, and I filled everything with -1. Okay, so here I only filled with, but I want to fill everything as -1. For int j is equal to 0 and j is less than n, j plus plus. So inside this, you will be assigning this particular line. Okay, so entire matrix will be of -1. Okay, so this is another line I changed. Then come here in my base condition. Here another line I changed. Okay, and before returning it, I must store in my dp array. So here I stored, right, and then return it. Can I understand this? Okay, fine. So this is going to be a memoization approach. Let me just shrink it so that I can copy this and teach you how I am going to do it in a tabulation. Okay, fine. So the next step is tabulation. So why we are going for a tabulation is, see here, listen this carefully. What is the time and space complexity? It is m cross n. So the space is because of two things. One is because of recursion stack, another one is because of the matrix we used. Okay, so we want to first eliminate this recursion stack. How we are going to eliminate this recursion stack? It is simple. Do not use recursion. If you do not use recursion, how I can iterate it, right? I can iterate it. If you don't want to use recursion, then you can iterate it. So the third step is tabulation, which means we are just converting into looping. Okay, looping. Okay, now in this also you want to focus on some things. Okay, from conversion from memoization into tabulation, you want to focus on something. So see here, what is the matrix we used already? Let me copy this matrix. So this is what the matrix we used in a memoization technique, right? Now I want to just modify the matrix at first. Check for modification. Okay, so see here, what is the base condition? Go to the base condition. If I is equal to m, what should I do? I want to take the sum of the all elements. Okay, so take for example, instead of taking this matrix, let me draw one. Just a minute. Let us take example delete and delete. Okay, Let us take that example. Delete, just a minute. Okay, so this is how the example looks like. Okay, now for this example, in your memoization, in this memoization, how your table looks like. Your table have 0, 1, 2, 3, 4 and 5. 5 rows and how many columns? 0, 1, 2 and 3 columns. Okay. And everything is filled with -1. Everything is filled with -1 in terms of memoization. But it is a tabulation, right? It is a tabulation. So you just leave as it is. You don't want to follow that -1 at all. Okay. Just leave as it is. Okay. Now see this particular base condition. If I is equal to m, which means I, which is equal to length of the string. Whether what is the length of the string here? It is 6. Whether I have for this I. So I means this all and j means these all, right? For this I, whether I have 6 as my one of the index? No. So add one more row. Add one more row. Can you understand this? Similarly, in my second base condition, j is equal to n. Whether j has any value as 4, because here the length of the second string is 4. Whether I have anything as 4? No. So add 4. Which means our dimension is changed into m plus 1 cross n plus 1. So this is our new dimension. Okay. Listen this. So see here, if my I is equal to m, which means it defines this, but highlight, I will be highlighting with white color. So it means this particular boxes, the last row. In this last row, what should I do? See here, sum is equal to 0 and k is equal to j and k is less than n and k plus plus, and then sum plus is equal to s2 dot caret of k. Okay, what it signifies? It signifies that you want to take from j up to n whatsoever element are found, you want to take them and add them and place them in that particular part. Okay, so here is what many of them will be doing wrong. Okay, so please listen this carefully. So I want to start from j and go up to n, right? Go up to n and add all the things and I want to return it. So see here, listen this carefully. Here it is leet. So I want to take this t's value and store at this particular point. What is the t's ASCII value? It is 116. Okay. Similarly, take this e and the t, these both the things, and store at this particular point. So it will be 101 plus 116, which is equal to 217. Okay. Similarly, take this e and store here. So 101 plus 217, which is equal to 318. Similarly, for this L also, what is the ASCII value of L? It is 108. So 108 plus 318. So this is how you want to fill the values at the last row. Similarly, for the last column, for this particular base condition, for the last column, start from this fifth row. So see here, E. What is the ASCII value of E? It is 101. So put 101. Next, it is T. So 101 plus 116, which is equal to 217. Okay. Similarly, here it is again E. So 101 plus 217, which is equal to 318. Again here it is L. So L means you want to add. So 108 plus 318. Okay. Similarly, here it is again E and D. So fill them here and here. Okay. Now listen this carefully. Now your matrix is ready for the computational purpose. Okay. Now another base condition is we have written here. If I is equal to m and j is equal to n, then I want to return 0. So here it is j is equal to n. Okay. N. It is not m. Okay. If it is so, I want to return 0. So at this particular point, I want to make this as 0. Can you understand this? So this is how our array is designed. Now Apart from this, all other body of the recursion, and skip this part, skip this base condition we added in the memoization part. All other are the body of the recursion, right? Whenever we enter the body of the recursion, start from the looping. For what is the first varying parameter? It is I. So I will be from where to where? So I will be starting from where? It is starting from 0 and going up to m. Going up to m minus 1. If it is reaching m, it will be base condition. So I is from where to where? 0 to m minus 1, which means in terms of looping, you want to reverse it, m minus 1 up to 0. Okay. Similarly for j, it will be starting from n minus 1 up to 0. Can you understand this? Yes. Now write the body as it is. Like if this particular line, if s1 of I is equal to s2 of j, then what should I do? Memo of I and j is equal to DFS. DFS means it is a recursion call. Whenever there is a recursion call, use the memoization matrix. Memo of what is a varying parameter? It is I plus 1, and another varying parameter is j plus 1. That's it. Similarly for the else part also. Else, here alone you want to change like memo of I and j, and here alone you want to change to memo of, here I plus 1 and j, here it is I and j plus 1. That's it. Okay. So that's what the change required. And after finishing all, what should I return? That's going to be the next crucial part, right? So in my memoization, what I returned DFS of 0, 0. Okay. So it is a recursion call. So instead of this recursion call, I want to use memo of 0 and 0. That's it. So this should be my return value. Okay. So this is how we will be converting the memoization code into a tabulation code. If you still have some doubts, just go and dry run this so that you can understand this clearly. Okay. Now what is the time complexity? It will be m cross n. And what is space complexity? It is also O of m cross n, but the recursion stack is eliminated. It is only because of the matrix we have used. That's it. So let me show you the code. So see here, this is going to be a tabulation code. Yes. So see here, the first thing I alter in the matrix is row and column will be incremented by 1, and then the base condition. For the base condition, I want to go from n minus 1 up to 0. Okay, and I want to take them all and add with the next value in the current value. Like see here, for the both the cases, here it will be like the single value, and here it will be like e plus t, and here it will be like e plus the next this particular column, this particular shell. Can I understand this? Similarly here, this 101 alone will be present here. When I go to here, then it will be like t plus this particular shell. When I go to here, I want to take this particular index character, like third index means I want to take this e plus what is its previous next index value, this 217. So this is what I added and kept here, right? Can I understand this? That's what I done in this coding path also, in this 4 lines. Okay. Similarly here, where should I start for looping? I will be starting from end and going to 0. Here also I will be starting from end and I will be going to 0 and one condition, and in this condition wherever the recursion occurs, just change into DP array. Similarly here also change into DP array. At last what should I return? See here in memoization I returned what? I returned DFS of 0, 0. Whenever there is a recursion call, you want to change into DP array, and what is the value you have added for the varying parameter? It is 0 and 0. So here also 0 and 0. Can you understand up to this, right? Now we are just getting into the next optimization technique called space optimization. So see here, space optimization. So like tabulation, the space optimization is also one of the optimization where we want to just shrink the usage of the space. Okay. Okay. So what are the steps we require to optimize the space? First of all, go to the inner loop and check how much we need and whether we used any extra space or not. See here, Here I used dp of I and j, and here I used dp of I plus 1 and j plus 1. Here also I used only dp of I plus 1, and here also I used only dp of I, which means this represent I only used previous row, sorry, next row and the current row. I didn't use the entire row. Can you understand this? Can you understand this? So I didn't use m rows. I only used current row and the next row. So from this I can tell you we only want 2 rows or 2 arrays of size n. So instead of this one particular line, I can make this as 2 lines, like one is of next, another one of current. So this next represent dp of I plus 1. I will be telling you how it represent. Here it will be dp of I. So here I will be taking a matrix of m plus 1 dimension, sorry, m plus 1 length, and here also it will be m plus 1 length. Okay, so this is one array and this is one array. Okay, now instead of taking these two things, I will be doing only one time in my next array. Like understand this clearly. We are taking one row alone, which means I am going to take all the columns. I am going to take all the columns. Like next will be initially representing this particular row, 6th row. Can you understand this? So if you have this same example, leet and delete. So delete and leet. Okay, 0 1 2 3. Okay, now I will be taking all this and filling here. Like here it will be 0, and here it will be, what is the ASCII value of t? It is 1 1. Just a minute. 116, and here comes 217, and here comes 318, and here comes 108 plus 318. Okay, so this is how I will be filling in my next. Can you understand this? I took the last row as my next, and current will be my last row's previous row. So here you don't want to fill anything. We are just going to compute here. Okay, so this is what you want to do instead of taking these two things. Okay, you want to do this step. I will be showing in the code clearly. Okay, now after this you want to put this for loop as it is, and between this for loop I want to add one more line. What is going to be that one more line? In my current I want to update it. Like current of n is equal to next of n plus at that particular point what is the character. So what is the character? So it will be s1, right? So s1 of I. Can you understand this, what I am doing here? See here. So this fourth column, this fourth column will be represented by n. Fourth column is represented by n, right? So at this n, if my current is pointing towards this point, okay, then I want to update here as 101. That's the reason why I am doing this particular line. I want you to dry run this so that you can understand this clearly. Okay, or else if you already solved so much DP questions from my playlist, then you can understand this clearly. Okay, if you are starting with this question, then it is quite difficult to understand. Okay, but I want you to just pause this video and just know why I am using this particular line. Okay, by seeing this particular matrix. Okay, fine. What is the next change I want to do? I want to just go and change this dp of I plus 1 into next, and this dp of I into current. Similarly here also dp of I into current and dp of I plus 1 into next, which means next of j, like that. Okay, and here also I want to change into current. Okay, and then after finishing this inner for loop, I want to add one more line. Next is equal to current. That's it. What it signifies? It signifies by using the next, I computed the current, and after that for the next iteration the next will be updated as the current. Okay, and then again the current is computed. In the next iteration, the next, by using the next, the current is computed. Like that, it will be going up to 0th in this. Okay, at last, what should I return? I'll be returning current of 0, or you may also return next of 0, because at this particular point both the array will be same. Can you understand this? So the core logic is, okay, follow my white color. At first I'll be taking these two rows. So where this is going to be my next and this is going to be my current. Fifth row going to be my current and sixth row is going to be my next. By using this next, I'll be computing the current, all these rows. Okay, in next iteration, 4 and 5 I'll be taking, where 4 is going to be my current and 5 is going to be my next, and I computing all the values for fourth row. Again I'll be taking 3 and 4, then 2 and 3, then 1 and 2, then 0 and 1, then I have all the values filled in my 0th row, where I'll be taking the 0th row's 0th column value as my result. That's it. Can I understand up to this, right? So this is what the space optimization. So once you wrote the code for tabulation, you want to check whether we can space optimize it or not. Okay, tell me what is going to be time complexity. So time complexity will be O of m cross n, and space complexity will be O of, see here, listen this carefully, O of n going to be my space complexity, because I only took, here I wrote m plus 1, so it is n plus 1, and here also it is n plus 1, which means length of the S2 plus 1. Okay, so this is what the space and time complexity analysis. Now let me show you the code. At this point you can understand this clearly. So see here, the first step is I want to take two arrays of size n plus 1. Okay, what is the next step? I want to fill all the values in my next as the value I stored in the matrix, the last row. What I did in the last row for the matrix, I did the same thing here for the next. Okay, and then for current I want to do in between of these two for loops. I want to update the current for each and every iteration, because we only have that one particular value for that one particular row. We don't take the entire rows. We didn't took entire rows, right? We only took two rows. That's the reason why I am updating the current at that particular point alone. Okay, and then wherever we have dp of I want to change as current, and wherever I have dp of I plus 1, I want to change as next. Similar for all the statements here, and at last I can either return next or I can return current also, because current I initialize here, right? So I can return wherever I want. So this is what the space optimization approach. I know this problem is bit confusing and understanding this problem is bit difficult. So I want you to dry run each and every approaches so that you can understand this problem clearly. And if you have any doubts regarding this, or if you found out any mistakes, just comment below. I'll be answering out the answers. And hope you really understood this problem and like this problem. If you really like this problem and like this video, and subscribe to my channel. Okay, and to know about these kinds of algorithms, just go and search in my YouTube channel, because there are plenty of algorithms and plenty of method wise problem solving. Okay, I don't want you to go with random selection. I want you to solve the problems in the topic wise, so that it will be useful when you are seeing a random problem. You can able to come up with which method I want to use for this particular problems. Okay, for that I just posted so many playlists of variety of methods. Thank you.